So, yeah, I think my voice was not audible earlier. So, welcome everyone to this live session, Ask AuxEn Anything, which is an online platform for civil engineers to interact with us and ask their queries or doubts related to project that they are doing or any steel RCC design concept or construction site related issues that they may have. So, this is the 23rd such session that we are conducting, and welcome all of you to this live session. So what we will do is, as we do always, we'll just take up the questions asked on the Google form first. Then we will take questions from the email, and then we will take questions from the live comments. So let's begin. And let me just do one thing. Yeah. So first question is, it's not a question, it's a comment by Snehal Biradar, and she's saying, it's not a question, I think it's a statement. So she's saying that her father used to manufacture small precast products such as precast manhole covers, compound walls, fencing poles, grating covers, etc. I wish to know how to apply structural engineering knowledge to design these small products, especially precast grating covers, fencing poles, and compound walls. I did not find any literature regarding design of these in our course. I will share images and my problem in more detail over a mail. Okay, so I have seen a few concept drawings for these types of small products like FRP, sorry, like precast poles or fencing poles, grating covers. So those design documents that I had seen, there the design was being done by the normal RCC design procedure. So I don't remember seeing any different specific code for it. However, there might be a code, but I'm not aware at this point. Uh, so those documents that I saw for these small items, they had done the design as per our normal IS 456 procedures. So yes, precast, as you might have seen in steel industry now, the gaining popularity of pre-engineered structures where the design fabrication is done in the workshop. Same will happen with RCC also in the times to come, because of course, because of lack of labor, because of strict regulatory norms, especially related to environment, and due to these issues you will see increase in the precast construction. So yes, you should pursue because you have it. I mean, it's in the family that you had this business. Your father had this business, so you should also pursue. But then you should also look at the FRP construction now, because FRP is also gaining a lot of popularity, especially for these covers, manhole covers, uh, and for light structural applications. FRP is also gaining popularity these days, especially with the use of construction manufacturing of not use manufacturing of different FRP structural shapes. So these days companies are manufacturing FRP shapes in the form of hollow or I sections or hollow pipes. So these types of low weight structural shapes are specially useful for railings, hand railings, or use in, let's say, light structural applications. So you could also have a look at FRP in addition to the precast industry experience and background that you already have. Okay, right. So have you added anything in the mail? I'll just check. Otherwise, we will go to next question. So Snail's question, it was not a question, it was a comment, and she is asking about the codes. There must be some code, although I'm not aware of uh, any specific code as of now, but I'm sure there must be some code related to it. Okay, right. So, okay, so she has not put any comment in the email. Okay, so let's move to the next question asked. And next question is from Engineer Shubham Kole. He is joining us from um, where is joining us from? Nashik. So he is a postgraduate student, and let's see what his questions are. So, what should be the slenderness limit for bracing because angle section may take tension or compression? So what should be the slenderness ratio limit? So it's uh, given in the code IS 800-2007. If you refer the table number 3, I'll just open and let's see if we can quickly discuss that table. So what I'll do is I'll just bring that table screenshot over here. Just give me a minute. I'm just bringing the screenshot. It's table number 3, I guess. Yeah. So slenderness ratio limits, table number 3, IS 800-2007. Right. So a member carrying compressive loads resulting from dead loads and imposed loads. So if your bracing is such that it may have compressive loads due to gravity loads also, then you need to restrict your bracing slenderness ratio at 180. If you are designing your bracing as a tension member, but in which a reversal of direct stress occurs due to loads other than wind or seismic. So let's say you are designing your bracing member in which, although you have designed it as a tension member, but there is a possible reversal of stresses, possible load reversal under gravity loads or under loads other than wind or seismic, then again you have to restrict it to 180 slenderness ratio limit. If you are designing your bracing uh, where where compression may result, just hold on, where compression may result, I'll be just back in a minute, just give me a minute, please. Yeah, so if you so if your member is subjected to compression forces, but that compression is resulting only from wind or seismic events, okay, then you can have your slenderness ratio at 250. If you are designing a member, bracing member that is, which is being designed as tension only member, and which is not considered to be effective under compression resulting from wind or seismic, then you can limit it to 350. So in most of the cases, if you are designing your bracings, generally they are designed as tension only bracings. The bracing systems that you see, stability bracing systems that you usually see in your structures, they are usually designed as tension only bracings. That means they are considered to be effective only under tension. And if there is a possible reversal and compression due to wind or seismic events, then they are not considered to be effective enough. So, in most of these bracings that we provide, the slenderness ratio limit that we adopt is 350 as per this fifth number clause. Okay. So that is what we usually do. So my suggestion to you would be that if you are designing these types of stability bracing systems, usually you can have a slenderness ratio of 350, and take them as tension only bracings. Okay. While designing connection for capacity, what should be considered moment and shear? As for moment connection, full moment should be considered, but shear force should be considered at full or 60%. And in same shear connection, full shear should be considered 60% of capacity. See, don't get confused with the 60% provision. That 60% is the demarcation limit between high shear and low shear case, between high shear and low shear. Okay, so that 60% is that criteria. Now when you are designing your connection, my first question is, why do you want to design it for the full moment capacity? Because it might not be the best economical option for you, so you might not be tempted, I would say, to design it at the full shear capacity, at the full moment capacity, unless you are doing some kind of ductility design. I would not suggest you to go for the full uh, capacity design for your connections. But let's say you have chosen to design it for the full capacity. I again will not suggest you to go for the full shear capacity, because it's very rare to see the structure getting stressed in shear and moment both to the full limit. So in my opinion, that chance is very rare that you get high shear. High shear means shear nearing the full capacity, and movement also nearing the full movement capacity. That combination is very rare. But let's say if you are adamant and you want to design it on the capacity level, then you go for the full movement, full shear. Do not be confused with the 60%. See, the 60% is a design criteria to account for the combined interaction of shear and moment acting together, and that too it's only in the British standard from where it was taken in the Indian code. So this option, or this way of interaction between moment and shear, is not there in the AISC codes. It's there in the British code. From there it has been taken in the Indian code. So do not get confused with that 60% criteria for high shear low shear design. Let's say if you want to design it at the capacity level, you take the full shear capacity, take the full moment capacity, okay, and then design. See, why I'm telling you that is because generally when you are designing for a connection, usually you will see that the shear is concentrated in the webs. So if you are designing the connection for full shear capacity, you will have to focus on connection system near the web. Okay, if you are designing for the moment capacity full, you will have to focus on your connection system near the flanges. So anyway, they are in a way mutually exclusive of each other. So that's why I'm saying, if you want to design it at the capacity, do it for the full shear, full moment. Don't be confused with the 60% criteria. Okay, all right. So this was uh, engineer Shubham Kole from Nashik. Next question is from Pratham Maskara. He's from Kolkata. Namaste, sir. How can I open my own structural design consultancy services? Currently, I am a fresher. So, if you're a fresher, do not think of opening your own consultancy service as of now, unless you get 5 6 years of experience at least working under some senior consultant or with some company. So, unless you have that 5 6 years of experience, do not think of opening your own structural design consultancy. The reason being that structural design consultancy, you are giving your suggestions, you are giving, I mean, people are going to come to you to take your opinion. Okay, you are going to consult them on a particular structural engineering project or related to a structural engineering topic. So people will not tend to listen to you unless you have some background. Okay, so in my suggestion, unless you have 5 6 years of experience, and that experience should be through working under some senior structural engineer, or through working in a company, unless you do not have that experience, do not think of starting your own consultancy. You can look at the other professions like doctors, advocates, lawyers, chartered accountants. They don't go and start their own firm straight away. First, they take experience under some senior or under in some company, and then they start on their own. So same is with structural engineering profession also. Okay. So work first, work for 5 6 years, then think of opening on your own, opening your own consultancy. Next question is from engineer Ashish Kumar. He is joining us from Rachi. He is an independent consultant, and his question is: he is designing a G+1 steel structure in which office first floor is for office purpose. Can you please suggest the flooring types which I can adopt? So if you are, let's say this is an office, then deck slab, that means steel deck sheet plus RCC topping will be a suitable option for you. At what distance you should place your secondary beams to support the floor system, that will depend on the deck sheet that you are choosing and on the live load that for which you want to design your office. But assuming that you are having around 2.5 kilonewton per meter square live load for your floor, and let's say you are using a 0.8 thick uh, normal steel deck sheet which is having around 50 as your crest height, then you can go for around, in my view, you could have somewhere around 1.2 to 1.5 meter of spacing between the secondary beams. Okay, secondary beams. So 50 crest height, 0.8 steel deck sheet thickness, assuming a usual live load of 2.5 kilonewton per meter square, the secondary beam spacing you can have around 1.2 to 1.5, and in this it will be, let's say, an average of 125 thickness total concrete slab. Okay, where 50 is the crest height, and it will have a 75 topping over the crest, total 125 RCC topping. So this type of an office floor you can come up with, and these secondary beams will be, so this deck sheet has to be essentially one way. These are essentially one way systems. So let's say your slab size, total office size was 5.5 by 8. Sorry, if it was 5.5 by 8, let's say 5.5 by 8, maybe you could come up with secondary beams in the shorter direction like this at every 1.2 meter, and then the deck sheet corrugation can run in this direction. Okay, so this type of system you can think of, but of course it will depend on your specific requirements. This is just a suggestion based on the data that you have provided. I hope that's clear. So this was engineer Ashish Kumar. Now let's go and see what other questions we have. Okay, so these are the questions asked on the Google form. Now let us take up questions from the YouTube comments. So Mr. Abdul is he's saying hi, hello. His next question is how to apply wind load for open building. So for open building, if you open building, I'm assuming there is no cladding, there is no obstruction. So then you could apply the CF factors. You could calculate the CF factors for your structural columns and beams. And as per those CF factors, you could apply the wind loads only on the exposed area of the member. That means if you, let's say you are having a I-shaped column, so then you calculate the CF for your I-shaped column, and then as per the column exposed surface, you calculate the wind loads. Same thing you do for the beams also, and in that way you apply the wind loads for it. So if I were to show you uh, a sample, it's given in table. So you have these tables, table 25. Wait a minute. So this table 25 from 875 part 3. Now, although it's written force coefficient for clad buildings of uniform section, that means here they are saying that your building shapes should be like this, but mostly this table is also used for individual shapes, individual structural elements also. I'll repeat, I'm saying, although it's written over here, force coefficient for clad buildings of uniform section, but this same table is used for individual structural elements also having this type of shapes. This is the plan shape of that structural element. So for example, if your column is a square column, okay, so square column, let's say you take up this shape, you can calculate R and all those things. I'm leaving that to you. Then you calculate the VD bar into B as per these values. First you calculate the h upon width ratio. So total height of your column, if it's, let's say if it is 12 meters, 3 floors 12 meters, and this dimension is 0.3, 300 mm. So 12 upon 0.3, you will get how much? You will get some 30, 3.33. So you will get some around 40. So that means your h by width ratio, it's more than 20. So you look for this infinite, and from here, let's say depending on the VD bar into B sum product, let's say you get the CF of 1.3. So that means when you are applying the wind load in this direction on this column like this, this will be the exposed area. So you multiply the CF into wind pressure into this exposed dimension into B, you will get a UDL. You apply this UDL along the column height. So in this manner, you can do the calculation. If your structural shape of your column is like an eye shaped or a channel shape, then you could use this also. Then you could go for this table 29 also. Okay. What many people also do is that they would take the values from this table 29. They will also take the values from table 25. If your shapes are, that means let's say it's a square shape. So in case of square shape, they will take it from here also. They will take it from table 25 also. Whichever is the higher value, that wind coefficient CF they will apply. Okay. Right. So this is how you can apply the wind load for an open building. Uh, Zidani is adding, if it's not high rise, wind load does not have any effect. Yeah, that's correct. So if it's an open building and if it's not a very high tall building, then this type of wind load that you calculate, it might not be of a very large magnitude, and it might not be a critical governing load as such. Right. Mr. Akshay Shitore is asking how to apply wind loads in ETABs for RCC framed structure when cladding is not modeled. So in that case, you could apply the wind loads on columns and beams as UDL loads, right? As columns and beams as UDL loads. That is the best way to do it if you have not modeled the cladding. So you apply the load in the manner in which it is going to get transferred on the structure, and then apply those loads as UDLs. That is the best way. Good. Then you have this question from engineer Akash Babar. He is saying, I have a steel platform located on terrace of an RCC building. No, so what is the question? I have steel platform located on terrace of RCC building. Where is the question? Okay, I think he'll put the question. In the meanwhile, let's see. Engineer Saurabh Patil is asking how to calculate BE main, BE other, mid main, other link. What is this BE main, BE other? Are you talking about the reinforcements, shear reinforcements? Okay, yeah. How to calculate ductile links for columns and shear walls. So you could refer to IS 13920. There they have quite clearly given what needs to be done, what needs to be done for boundary elements, when in which case we need to provide confinement reinforcement in the boundary element, what needs to be done for the web portion of the shear wall. All those details are quite clearly given in the IS 13920 part 1. Sorry, IS 13920 is only one part. So IS 13920 2016, you just refer over there. They have adequately answered your doubt over there. Okay. So see, mainly in the shear walls, in the web portion, because web portion does not have to. So let's say you have this kind of a shear wall, and this is your width of boundary element as per your moment and all the requirements provisions. So generally over here we provide the confinement reinforcement spacings. So as per the confinement reinforcement requirements, we provide the ductile links over here. Here it is governed by the minimum horizontal reinforcement spacing criteria. Okay, so this is generally what we do. So these values and this explanation is given in the IS 13920. You could refer over there. If you have any specific doubt, then ask. Engineer Arbaz Kazi is asking how to design pile cap tie beam for minimum eccentricity. Minimum eccentricity from where? See, one way can be that you model your tie beam in the same model where, let's say, if you are doing some computer modeling, you could model your tie beam at the same place where you have modeled your pile caps. Have your pile caps on spring supports. Sorry, have your pile points on spring supports, and have the column loads assigned, and then connect it with tie beams. So automatically you will see the appropriate moments getting transferred to tie beams, and then you can design that tie beam for it. Okay, right. Engineer Pankaj Singh is asking, can you explain LX and LY parameters? Sometimes I am really confused in these parameters. How many basic parameters we have considered if we use stat software? See, explaining this will take time. So maybe you could, what should you do? Maybe you could refer some YouTube videos. In our steel courses, we have discussed in the basic steel course that we have covered, that we have conducted, we have discussed these LX/LY parameters, LX/LY, LZ in great detail. So I would suggest that you should take that course. It will really help you in understanding all these parameters. Uh, so if you have any specific doubt related to it, just ask it over here. Otherwise, you could watch some YouTube videos or join our course. I think that will really help you. Short answer, LX parameter, if I talk about as per IS 800 2007, your LX parameter is for the lateral torsional buckling, defining lateral torsional buckling length for flexure. LY, LZ are for flexural buckling for compression. Okay. So this LY, LZ that you define, it is used for compression capacity calculation as per chapter 7. And this LX parameter that you define, it is used for LTB calculation, lateral torsional buckling length calculation for flexure, as per chapter 8 of IS 800 2007, I am saying. So how to define it, and in which case, how to understand this, I would suggest you to watch some YouTube videos, or as I just said, you could perhaps have a look at our basic course in steel design, where we have discussed this in a lot of detail. Now, usually this LX and LY parameter numerically are the same. So whatever LY you give, it is the same value for LX also that you have to give, usually speaking. Okay. And if you, because we have been conducting a course on AISC steel design as well, so we have understood a few things now related to AISC. So in AISC code, your LX parameter is used for the torsional buckling, for for compression calculations, torsional buckling for compression calculations. LY LZ are used for flexural buckling for compression calculations. And then for LTB, lateral torsional buckling, they have given you other parameters like UNB and UNT. So these are for LTB, for flexural calculations. So usually this is how it is done in the AISC code. So for details, you could perhaps, as I just told, refer some YouTube videos, or go to stat documentation, or contact me for further details. Okay. Mr. Akash Babar is asking, is there any YouTube playlist of all the old Ask AuxEn Anything sessions for viewing? I'll just make that playlist. Although there's no playlist that has been created, but I'll just update uh, a playlist. Okay. Yes. How to reduce the self weight of the structure? Reducing the self weight, there might be different strategies involved. One can be to change the material. That means, let's say, not go for RCC, go for structural steel. Uh, Other options could be to use lighter partition walls. For example, not to use solid clay brick walls. Instead, use some AAC blocks or fly ash bricks. Another option could be to have a structural framing which reduces the self weight of the structure. Another option could be, in your flooring, try to make your flooring lighter by, let's say, using uh, ribbed slabs or hollow slabs. These for reducing the self weight. In most of the structures that we do, usually what happens is that your self weight is a significant chunk of your overall structural weight. Okay. So you had designed your structure, or you want your structure to take live loads, but then that live load magnitude sometimes is lesser than the dead load magnitude of the structure. So that is not a very good design. Okay. That is not a very good design. Generally, your aim should always be to reduce the self weight or dead load of your structure as much as possible. Right. Engineer Akshay is asking, can you make a course on cold form steel structures? Yes, we will do. We'll do in a near future. That has been in the list for a long time now. We will do it pretty soon. Okay. Yes. Any other questions? Any other question, please? Okay. There are a few questions that were asked on uh, in the WhatsApp chat. So let me just see if I can find it. If there are any more questions, just type in your comments. Mr. Akash Babar is asking, is there any all India license system for structural engineers? No. Or is it state specific? It is state specific, but these licenses nobody asks, in my opinion, unless you are doing some structure which has to be certified by a municipal authority. Nobody is asking for these uh, licenses. Okay, so in India, this license system is not of that significance as it is for some other professions, like uh, like maybe a doctor or a lawyer. For structural engineers, this license system is not so much of any significance. Engineer Harish Acharya is asking for monoslope roof truss, how to calculate the wind load. So it's quite clearly given in the IS 875 part 3. Table number is, I guess, uh, which is the table number. I'll just show you the table. So for monoslope roofs, you can refer to table 7. If it's a monoslope roof of a rectangular clad building, then you could refer to this table number 7. If it's a monoslope roof of a freestanding structure, freestanding mono roof, that means it does not have any cladding or a wall system below it, then you can refer to table 8, that is the monoslope free roofs. So this table 7, table 8 you have for this. Engineer Allah Baksh M is asking how to design and detail triangular shaped slab. So for triangular shaped slabs, you will have to first see what type of yield lines are being created depending on the type of load. So if you're not sure of the yield lines, best way I would say is to make a small model, because yield lines is theory will not work over here. Uh, so make a small model and then look at the moment contour, and as per the moment contour find out the moments. Reinforcement placement can always be in this type of a direction, like this. And for triangular, you may provide some corner reinforcements also, maybe in the form of a mesh, just like we do in a rectangular slab at corners. Maybe you could come up with some rectangular mesh like system for the corners. Okay, so in my opinion, it is best to design it in the computer model, or you should have the appropriate yield line pattern for it if you want to do it manually. Engineer Pranav Sapra is asking, could you please highlight key factors or parameters to consider for designing 4 meters tall RCC retaining wall in STAD for an for a seismic zone 5? See, so key parameters would be, if you want to design a retaining wall and it's 4 meters, I'm just assuming this type of a shape. This is your ground level and this is the fill level, and this height is 4 meters above. So the above ground fill is 4 meters. So what you want over here will be the dynamic pressure that will be exerted. Okay, so how much increase in this dynamic pressure that you will have when it is acted upon by the earthquake, that you need to find out. So I think for this, although I have not thought about it before, but there is this IS 1893 part for retaining structures, which is the IS 1893 part for it. I will just look and tell you. So although I have not done this type of a structure before where we had to design a retaining wall in a high seismic zone, but then what I can understand is that there might be some change in the active pressure coefficient due to the effect of seismic shaking, and I think that will get covered in. I'm just looking for which part. Part 3. So maybe you will have to go to part 3, and over there, my understanding is that they would give you some dynamic value of Ka. As per that, once you get that, and then you could design your retaining wall as per the normal procedure. Mr. Pranav Sapre is asking, with vehicle surcharge load of 60 metric tons on top of retained soil. Okay, so he has surcharge load also over here due to some vehicular movement. There might be some surcharge load. Yeah. So personally, I have not done this type of structure in high seismic zone. So IS 1893 Part 3, I think you should refer. You might get some dynamic values of Ka over there, and then you could continue with the normal procedure of retaining wall design. Good. Yes. Anything else? Okay. So then there was a question asked by Engineer Rahul Brijpuria on my WhatsApp message. So I'll just see. Temperature loads. He had asked a question about temperature loads. So temperature load, how to apply temperature load? He had asked. So let me just quickly answer this. So temperature loads as per temperature loads instead. No, I think he was asking as a general question. So generally temperature loads, if you are applying it on member, so then it is applied as it can a possible change in temperature can cause elongation or contraction. If your temperature is above ambient, it will cause elongation. If it is below ambient, it will cause contraction. So your general ambient temperature is taken as 27 degrees Celsius. Now you will have to find out at your location what is the maximum temperature that can reach and what is the minimum temperature at your location. Your location means wherever you are designing this. So there you need to find out the max and min. That can be found out from IS 875 part 5. So there are ISO, I think they call it as isothermal maps, where they will give you the minimum maximum temperature. So suppose the maximum temperature at your location is, let's say, maybe 50 degrees Celsius, and minimum temperature reaches 3 degrees Celsius. So what is the elongation? Elongation will be caused due to a delta of 50 minus 27, so 23 degrees Celsius. Contraction will be caused due to a delta of minus 24 degrees Celsius. So you go to your software and make two temperature load cases. Let's say one is temperature above ambient, one is temperature below ambient. In these load cases, put these values and apply it to your members. Okay, and then the software will automatically calculate the elongation, contraction, and based on that it will calculate the uh, restraining moment, shears, etc., axial forces, etc. So this is the IS 8, this is the normal way given in IS 875 part 5. There is a slightly different way. Yeah, sorry, if it is a floor system, if let's say this was a slab, this is slab top, this is slab bottom, and if there's a temperature differential between the slab top and bottom, then you have to give this temperature differential in the software, and then it will calculate this differential between the top and bottom, and accordingly it will calculate the restraining moment, shears, axial forces, etc. So if you go to STAD or if you go to ETABS also, you can apply temperature loads on members or on your shell elements. Clear? Right. His next question was related to some slotted holes. Engineer Rahul Brijpuri had asked. So, cold form purlin slot holes. What was his question? Hmm. He had asked something about the continuity of purlins if we are providing slotted holes. I think that was his question, that if we are providing slotted holes in the purlin to purlin junction, at the purlin to purlin overlap, that is, how do we consider it to be a continuous purlin? I think that was his question, something like that. So usually those slots, what I have seen is, let's say this is your rafter and there is a purlin over here. So usually these, so this is one purlin. So usually that slot is not provided first of all over the rafter. That slot is usually provided some 350 to 370 or 700 mm away from this rafter. And now these slots are, I think, 6 holes or 4 holes or 8 holes like that. So even though there are slots over here, I think because of the manner in which the continuity forces will act, it still provides effective continuity over here. Although I will also have to think more about this, that how exactly these slots are designed, how exactly these slots are provided. I'll also have to think more about it. But because of multi-grade slots that are provided, and it's not a single bolt hole with a single slot, it is still able to maintain its continuity. I think Rahul has shared some WhatsApp image. Let me have a look. What is he saying? So temperature load application is slightly different in the IRC6. Okay, so there are two ways of temperature load calculations. One is the temperature load calculation given in IRC6, that is slightly different from what I explained over here. And one is as per IS 875 part 5, which is a simple temperature that is above and below. And one of the ways is the IRC6 approach. So there is a difference in these two approaches. Okay. So you need to look at the IRC6 approach also, and you need to have a look at the IS 800 2007 approach also. Okay. About this continuity, I'll just come up with figures, diagrams, and then I think we can have a better discussion for it. Engineer Pankaj Singh is asking if a steel column is fixed with base plate, so what support I should consider instead, pin or fixed but support. See, for that you need to see what kind of bolt layout, what kind of anchor bolt layout you have provided, and what is the stiffener gusset arrangement. As per that, you will have to decide whether your column will behave like a fixed support or a pin support. Generally, if your layout, bolt layout is something like this. Let's say this is my base plate in plan view. This is my column. Now, usually what this people do, if they want to provide a pin-like support, they'll have their bolt arrangement only in the web portion. Flanges, near the flanges, there is no connectivity provided. So this type of connection can be idealized as a pin-like connection. If you provide an elaborate gusset system with bolts in the distributed in the periphery like this, with enough stiffener and gusset plate arrangement, then, so this is my gusset arrangement, let's say, stiffener and gussets, then you could idealize the system as a fix like system. Okay, so it depends on the layout of your bolts, and it depends on the manner in which you are providing stiffeners and gussets. Clear? Okay. Any other question we have? So I think that is all we have for this week. There are no questions, no further questions on the Google form, no further question on the live comments also, and nothing in the WhatsApp chat as well. Prod is asking, in case of these fixed connections, how to determine the anchor length. So for anchor length, you need to see it should not have slip. Okay, slips have to be avoided. So the bond length of that anchor bolt should be sufficient enough. You have to avoid a cone-like failure. So you will have to calculate that as well. Now this cone-like failure calculation is not clearly given in the IS 800. So for that you need to go to AISC and ACI codes. So basically bond length shall be sufficient for these anchor bolts. You need to check for their cone-like failures also, and then you have to calculate the length of these anchor bolts. Mr. Allah Baksh is asking, what is direct analysis as per AISC? It's a long topic and difficult to explain it on live session like this. Right now, at present, we are conducting a complete course on AISC based steel design, where we have spent a lot of time in discussing the direct analysis procedure as per AISC. So you may uh, send me a message on WhatsApp if you want to know more about that course. So it's a long explanation. I will not be able to cover it in a live session like this. For more, if you're more interested, there are some good videos on YouTube. Go to Bentley Systems YouTube channel and just type direct analysis method. They have given a good procedure and good explanation of direct analysis procedure. Okay then. So that's all I think we have for this session. We will meet you next week now. If you have, so you can keep on adding your comments, questions in this Google form. Once every week, we meet on a weekend and take up your queries. But this Google form is the same form which we provide every time. So uh, you can just click on this Google form, and then keep putting your queries. And for personal chat on WhatsApp, this is the link for direct WhatsApp message I'm putting it in the comment section also, live comments. So if you want to message, then you can always message us on this link. So I think that's all for this week. We'll see you next week now. Thank you, uh, and have a good weekend. Bye bye. See you next week now.